Hi there, and thanks for joining me in this episode of ML in a Minute. I'm Terry, co-founder of Remix AI and your host. Today I want to chat a bit about LLMs with tool augmentation, picking up from last week's episode. So if you didn't see that, then check it out. It's on the screen here. We were motivated by the use case of trying to perform video production, video editing workflows through a chat UI. And so in that episode, we discussed FFMPerative, a package we open sourced to do this. It basically works by using Hugging Face's agents with tools to wrap FFmpeg Python. And we created a bunch of handy tools for practical workflows you might want to use on multimedia. And as a part of this project, we also open sourced the dataset. The FFMPerative dataset features hundreds of examples of practical workflows that compose the tools that we've open sourced through FFMPerative. And we use this so that we could combine with the Code Alpaca 20K dataset to build something we could fine-tune an LLM to use our tools for. And when Llama 2 was released, we were excited to be able to release the FFMPerative 7B to Llama 2 7B checkpoint. So now users of FFMPerative could pull the model and run it locally. But they're still going to need some hefty hardware GPUs to do that, and it's not going to be very fast. We were also excited about the Llama CPP code that we mentioned last week. And using 4-bit integer quantization with this code, you can run on CPU a little faster. But ultimately, we didn't really want 7B models or even 3B models. Maybe we were hoping that for a narrowly defined application like FFMPerative, we might be able to get away with 1 billion parameters. We didn't mention it, but we had started looking into Andre Karpathy's baby-llama, part of what he calls micro-LLMs. So think of these LLM architectures scaled down into the tens or hundreds of millions of parameters instead of billions. It may end up being very fast to run locally on CPU. He shows these 15 million parameter models making pretty plausible stories based on training from scratch on the Tiny Stories dataset, also featured in Hugging Face. Andre also mentions the chinchilla paper, an important result that gives some intuition about how you want to scale the parameter counts for the models along with the scale of the data and how that might scale with the amount of compute it takes to train all of that optimally. And so in this table at the bottom of the chinchilla paper, we see most of these results are for models that are a lot bigger than what we're interested in, and we need to extrapolate from this. But you can do the math, make a helper function with ChatGPT, and come up with a handy utility to help you estimate which parameters are going to work best for training your model, so that we could download the FFMPerative and Code Alpaca 20K datasets, format them for training in this model on a much smaller architecture, like the 15 million parameters. And initially, we pretty much stuck to the defaults, but found that the model was quickly plateauing and the output didn't really seem to reflect the FFMPerative dataset that we were training it with. And so we realized we could probably bump up that learning rate for such a small model. And we were also interested in expanding the context window. We took it to about 1K, and we otherwise stuck with a lot of the defaults here, adjusting to saturate the GPUs. You can see the healthy GPU utilization as we're training this model. We're coming up on the end of it where it's scheduled to train for 100,000 steps. And the loss started at around 10. It's below 0.01 or so now. And with that, we can see that the model is reaching for tools that aren't necessarily fed as part of the input prompt. It does recognize the video editing workflows and it's reaching for tools, but it's not quite getting the ones that we're looking for. And when it does, it doesn't necessarily fill in the inputs correctly. So we're thinking about retraining this model, maybe scaling scaling up the parameter count by an order of magnitude, and really exploding the data set with more variation on the inputs. We want to train with more of the training samples, including lots of the context that would be presented to the model at inference time around tool use. So we're going to expand that FFMPerative data set and retrain, try to get more of the optimizations that are available from baby-llama. There's ways that you can parallelize this across different hardware setups that you have. And as we mentioned in last week's video, besides training a model to be specialized for tool use and video production, we're also interested in experimenting with code production workflows and agents that can help with that. And so you can use GPT-4 to come up with ideas for different designs that you might choose, different utilities that LLMs could help perform, opening branches and doing simple things like linting or creating documentation, doing things like explaining code could be handy for onboarding new people to a complex code base. So we're thinking about ways that we can design more tools to assist in the integration of the models that we're helping Remix AI users create on the cloud, so that through chat they can design new models, through chat locally with an agent that's not demanding too many resources. They'll be able to quickly pull those models, integrate them into code, expand on the machine learning application that they're designing. That's all I have for this week. Thanks for joining me, and feel free to subscribe to our newsletter or to this channel. I'm Terry of Remix AI signing off until next time.